Please do subscribe to our Nehra Classes YouTube channel and also turn on the bell notifications to receive the updates of our videos directly in your device. Hello everyone, my name is Vikas Nehra and you are watching Nehra Classes YouTube channel. Friends, in today's tutorial, I am going to show you the configuration of high availability cluster in CentOS 8 or RHEL 8 based machines. But before proceeding further, let me give you the brief idea about HA clusters. High availability cluster is also known as the failover cluster or the active passive cluster is one of the most widely used cluster types in a production environment to have continuous availability of services even one of the cluster nodes get failed. In technical, if the server running application has failed for some reason, the cluster software will restart the application on the other working node. Here, we will configure a failover cluster with Pacemaker to make the Apache server as a highly available application. And for this tutorial, we are going to use these 4 machines. And out of these 4 machines, 2 machines we are going to use as the cluster nodes. The other one we will use as the iSCSI shared storage. And the last machine we will use as the virtual cluster IP. Let me show you with the help of diagram. Here we are using this iSCSI server for the shared storage, and we have one virtual server, virtual IP, where we will host the web applications, and we have 2 different nodes which will allow us to connect or use this shared storage with the help of virtual IP. So clients can directly connect to iSCSI server shared storage with the help of these 2 nodes, and at one time we have one active session. Let us suppose if we are using this active session through node 1, and in case if something goes wrong and this session gets disconnected, in that case the cluster will switch over the connection to the other node. So without wasting time, let's get started. To show you the configuration of HA cluster, we are using 4 machines. Out of these, this first machine will work as node 1, the second machine will work as node 2, the third machine we will use as iSCSI server for the shared storage, and the fourth one we will use as the virtual IP where we will host the web application. These all 4 machines are running on CentOS 8. So in order to configure the HA cluster, we will log in the machines as the root user, and we will make sure that the local yum repositories are already properly configured in all these machines. So first of all, we will configure the shared storage. So we will go to the iSCSI server and we will install the target CLI and LVM2 packages from the local yum repositories. So here you can see that the packages are getting installed, and we have successfully installed these packages in our machine. Now in the next step, we will go on the first node and we will install their iSCSI initiator utils and LVM2 packages. Same we will do on the other node. These packages are already installed here on node 1. Now I will go to the node 2 and here I will install both these packages. So here also these 2 packages are already installed. Now we will go to the iSCSI server and here we will set up the shared storage disk. So for that we will execute fdisk-l command. Here you can see that I have already added a disk of 10 GB. Now with the help of this disk we will create LVM here. So first of all we will create the physical volume. So we will execute pv create command for the same pv create /dev/sdb. So we have successfully created the physical volume. Now we are going to create the volume group. So we will execute vg create command, then the vg name, and then the physical volume. And after that we will create the logical volume with the help of lv create command. lv create -l and the vg name, lv name, and then the vg name. So we have created the logical volume as well. Now in the next step, we will go to both the nodes and we will execute this command. command is cat etc iSCSI initiator name and dot iSCSI, and here it will generate the initiator name with IQN. Same command we will execute on node 2. So here also we are going to execute the same command, and it will generate the IQN number here on the node 2 as well. Now we will go to the iSCSI server, and here we will execute the target CLI command, and it will take us to the command line interface of iSCSI. Here we will first go in the backstores block directory. So we will use cd/backstores/block command. So here you can see that we have now moved in backstores block. Now we will create iSCSI shared storage. So we will execute create iSCSI underscore shared underscore storage command. Then we will mention the complete path of our LVM. So we have successfully created the storage object. Now we will move to the iSCSI directory, and then we will execute the create command there. So it will create the target IQN number and target portal group TPG1. Now we will move in IQN, then TPG1, and then we will go to the ACLs there. Now we will create the node ACL for the IQN. So here we will mention the same name that we have generated on the nodes. So this is the IQN number. We will use the same IQN number here. First we will do it for the first node, and then we will do it for the second node. So here you can see that we have successfully created node ACL for both the IQN numbers. Now we will move to the LUNs. So we will execute cd iSCSI IQN number, and then we will mention here TPG1 and LUNs and press enter. So we are inside now TPG1 and LUNs directory. Here we will create the LUNs. So we will execute create backstores block iSCSI shared storage command, and it will create the LUN0 here, and which will be mapped to both the nodes. Now we can execute here cd/ command, and if we do the ls, then you can see the LUN here that we have created from the LVM. Now we can save the configuration by save config command, and now we can exit. Now we can restart the target by systemctl restart command, and we can enable the same as well. Now we will add the rule for the firewall. So we can execute firewall-cmd-permanent-add-port, and we will add the port 3260 that runs on TCP in the firewall, because iSCSI traffic will use this port, and then we can reload the firewall so that this rule can get implemented. Now we will check the IP address of our iSCSI server. We will verify the IP address. IP address is 192.168.1.109. Now we will use this IP address, and we will execute the ISCSI ADM command to discover the LUN on the nodes. So here we will mention the IP address after this command, 192.168.1.109. So it has discovered the LUN. We will follow the same process on the node 2. Here also we have discovered the LUN. Now we will map this LUN on both the nodes. So on node 1 we will execute iSCSI ADM-M node-T and the IQN number of the LUN, and then the IP address and -L command, which will add the LUN on this node, and same we will do on the node 2. Now if you will execute lsblk command, then you will find this drive, that is SDB of 10 GB, which we are getting with the help of the iSCSI server on both the nodes. Here also you can see this SDB of 10 GB. Now in the next step, we will go to any of the nodes. Let us suppose I go on the node 1, and there I will create the physical volume with the help of this SDB disk. So I will execute here pv create /dev/sdb command, which will create the physical volume in my machine. And after that, I will create the volume group there with the name as vg_apache by the same physical volume. And then I can create the LVM there with the help of lv create command. And I will give the name to this LVM as lv_apache. Now we can format it in ext4 type file system, so we can execute mkfs.ext4 and then the complete path for this LVM. So we have successfully formatted it as well. Now we will go on the other node and we will scan these physical volume groups and the LVMs. So first we will execute pv scan command, then we will execute vg scan and then lv scan. So all these physical volume group and the logical volumes must be displayed on the other node as well. So here you can see that we are able to see this VG Apache here in the volume group and the LV Apache in the logical volume. Now in the next step, we can execute the lv display command and the LVM name to see the more details of this LVM on the other node. So here you can see that we are able to see the details of this LVM, that is of 10 GB, which we have created on the node 1, and we are able to see these details on node 2. That means it is working perfectly fine as the shared storage through iSCSI server. Now we will verify the IP addresses of both the nodes so that we can make an entry in the hosts file. So one node is having the IP address of 192.168.1.126. So let me make an entry in the hosts file for both the nodes on node 1, and here we will mention the IP address, and then we can mention the name node1.nehra classes dot local, or we can mention here Nehra classes node1 dot Nehra classes, like this. And on node 2 we will verify the IP address, that is 192.168.1.119, and we will make an entry for that as well here. Node 2 dot Nehra classes dot local and node 2 dot Nehra classes dot local. We will mention both these entries here on node 1, and same we will do on the node 2. So save this file and go on the node number 2, and here open the etc hosts file in vi editor and follow the same process that we did on node 1. Save this file as well. Cluster packages are available in the high availability repository, so we will enable it with the help of yum config manager command on both the nodes, and after that we will install the packages yum install -y pcs fence-agent-all and pcp-0 conf. These are the packages that are required, so we will install these packages on both the nodes. Let me execute this command on node 2 as well, and this process will take some time, so I'm going to pause the video for a while. You can see that the packages are getting installed on both the nodes. There are 106 cases, 6 packages that needs to be installed in my machine, and this process will take 5 to 10 minutes depending on the capacity of your machine. So I will again pause the video for a while and I will show you once the packages are installed. Here you can see that the packages have been successfully installed on both the nodes. Now we will add the rule for the high availability traffic in firewall. So we will execute firewall -cmd and we will reload the firewall to implement this rule, and we will do it on both the nodes. So here you can see that we have added high availability and we have reloaded the firewall on both the nodes. Now we will set the password for HA cluster. So we will execute passwd HA cluster command, and here we can define the password. So we have set the password. Same we will do on the second node as well. I have set the password on both the nodes for HA cluster. Now we will restart and enable the PCSD services on both the nodes so that it can start at its own even after rebooting the machine. Now we will create the cluster. So we will go on the node 1 and here we will authorize. So here we will execute PCS host auth, and then we will mention the host name, that is node1.nehra classes.local, and we will mention the host name of the second node as well, that is node2.nehra classes.local. So here we will press enter and then it will prompt us for the username. Here we will mention HA cluster and then it will prompt us for the password. So we will provide the same password that we have set. So it will authorize both the nodes. Now we will create the cluster, and for that we will execute PCS cluster setup command, and then we can mention the cluster name. We can give any name, then hyphen start, then the name, host name of the first node and the host name of the second node. So here you can see that we have successfully set up the cluster. Now we will set up the cluster to start automatically on a startup of the machine. So we can execute PCS cluster enable hyphen all command like this, and it will enable the cluster and it will start at its own on rebooting the server. We can also check the cluster status by PCS cluster status command, and it will show us the details of the cluster. It is showing the details for both the nodes as online. To get the detailed information, we can execute PCS status command. If you are using the fencing devices, then it's okay. But if you are not using fencing devices, then you can disable them by executing PCS property set stoneth -enabled is equal to false command. After disabling the fencing devices, we can install Apache on both the nodes. So DNF or the yum install Apache yum install -y httpd command we will use. Same command we will use on node 2 as well. And it will hardly take 20 to 30 seconds to download and install the packages. Once the packages are installed on both the nodes, we will open the etc httpd.conf file, that is the default file for the Apache on both the machines, and we will open this file in vi editor and we will make some changes there. So after opening the file on both the nodes, we will go at the last line of this particular file and there we will paste few lines. So go at the last line like this, go in the insert mode and paste there these lines. Location, set handler, require local, and close this location. And after that, save this file. Same we will do on node 2. We will again go to the last line of this particular file on node 2. And then we will go in the insert mode and paste these lines there as well. Like this. After that, we can save and exit this file. Now we will edit the Apache web server log rotate configuration to tell not to use the systemd as cluster resource and doesn't use systemd to reload the service. So here we can execute this command bin ctl reload httpd.service like this on both the nodes. So here we will execute this on first node first and then on the second node. After that, we will copy usr sbin httpd like this, and we will execute the command on both the nodes. Now we will use the shared storage for storing the web content, that is HTML file, and we will perform the below operation on node 1. So we will mount it on mount the LVM on where www. So first we will go on the node 1, and here we will use the mount command like this. There we can create the directory with the name as HTML in where www, and there we can create another directory with the name as cgi-bin like this. Again we can create another directory there in where www with the name as error, and then we can execute restore con command for SE Linux, so that SE Linux can generate the context. Then we can create the file in where www HTML directory with the name as index.html, and there we can mention anything like this. You can mention any details. We just want to check the working of our cluster like this. Let me open this file and check the contents slash where www html and index.html is the name of the file. Then we can unmount where www directory, and after that we will allow Apache service in the firewall on both the nodes. So we can execute firewall-cmd -permanent -add service is equal to http. So we will execute this on first node, and then we will execute it on the second node as well. After that we can reload the firewall on both the nodes to implement this rule like this. Now we will create a file system resource for the Apache server. So we can execute pcs resource create command for the same. So we will go on the node 1 and we will execute this command there like this. Now we will create the IP address resource. So we will check the IP address of our virtual IP server, and the IP address is 192.168.1.112. We will use this IP address here in the command on node 1, and here we will execute pcs resource create httpd command, and here we will mention the same IP address. So let's go to this location where the IP address is mentioned, and we will mention here the IP address as 192.168.1.112. Yes, this is the IP address. So we will mention the same IP address there and press enter. So here you can see that it is showing us as heartbeat IP header 2 detected from IP header 2. Now what we will do in the next step, we will create an Apache resource to monitor the status of the Apache server that will move to the resource to the another node in case of any failure. So for that we will execute this pcs resource create command like this. Now we will check the status with the help of pcs status command, and it is showing the details of our cluster. Now we have set the cluster, we have configured the cluster. We are going to check the working of the cluster now. So we will open the web browser and we will mention the IP address here. That is the virtual IP address that have we set, and the IP address is 192.168.1.112. So it should show us the default web page that we have created there. Press enter. So here it is showing us the details of the web page. Hello, welcome. This is this page is served by Red Hat High Availability Cluster. That means we have successfully fully created the HA cluster and we are able to see the web page. It means it is working fine. Now we will test whether all the nodes are working or not, whether it is working as the cluster or not in case of the failover condition. So now what we are going to do to check the failover of the resources by putting the active node in standby. So we will execute pcs node standby command and we will check whether it is working no or not. So we will execute pcs node standby and there we will mention the host name of node 1. The command has been executed. Now again we will refresh the page and in that case it should show us the same page because only one node is in the standby. Here you can see that we are able to access our web page. That means the HA cluster is working perfectly fine. We have some commands that we can use for cluster. If we want to list cluster resources, in that case we can execute pcs resource status command. If you want to restart cluster resources, you can execute pcs resource restart and after that you can mention the resource name. If you want to move the resource off a node, in that case you can execute pcs resource move and the resource group and the destination node name. If you want to put the cluster in maintenance, then you can execute pcs property set maintenance hyphen mode is equal to true. If you want to remove cluster from maintenance, in that case you can execute pcs property set maintenance hyphen mode is equal to false. If you want to start the cluster node, you can execute pcs cluster start and after that you can mention the node name. If you want to stop the cluster node, you can execute pcs cluster stop and the name of the node. If you want to start the cluster, you can execute pcs cluster start hyphen hyphen all. If you want to stop the cluster, in that case you can execute pcs cluster stop hyphen hyphen all, and if you want to destroy the cluster you can execute pcs cluster destroy and the cluster name. And in case if you want to use the web interface, then you can use the IP address. Let us suppose the IP address of my node is 192.168.1.126. So I will go on the web browser and there I will mention https colon double forward slash the IP address and mention the port number as 2224. If you will press enter here after mentioning the IP address and the port number, it will ask you for the username and the password. You will go to the web console of HA cluster and here you can mention HA cluster as the username and you will mention the same password that have you set while configuring it, and then it will take you to the management console. Here you can manage the clusters, you can manage the permissions. So here you can see that we are able to see the name of our cluster as the Nehra classes underscore cluster, and if you will click on this name, you will be able to see the both nodes there. Here it is showing us both the nodes, node 1 as well as node 2, and it is showing the node 1 in red color because we have set the node 1 in this standby mode that is not working, and we are able to use our cluster only on node 2 now. That is why it is showing everything for node 2 as green. Here you can see that Pacemaker is running, Corosync is running, PCSD is also running, and there there are different options available in the web console of HA cluster. Here you can see and add or remove the nodes in the nodes tab. In the resources, you can manage the resources, you can manage the fencing devices, you can mention the manage the ACLs here in the ACLs tab. You can see the cluster properties, you can manage the cluster here on the manage tab, and there, if you are not able to see your cluster here, you can add it by clicking here on the add existing option, and here you need to mention the node name, that is node1.nehra classes.local, like this, and after that it will automatically add your cluster there. I have already added this, that is why it is showing this here as Nehra classes underscore cluster. In this way you can easily configure and manage your cluster, and you can also use the web console to manage and see the details of your high availability cluster. Now what I'm going to do, I'm just going to stop this cluster and destroy it. So for that I can execute pcs cluster stop command to stop all the components of this cluster, and after that I can destroy it by using pcs destroy command, pcs cluster destroy and hyphen hyphen all, so it will destroy everything. So guys, that's it for today's session of HA cluster configuration. Hope you guys will find this video useful for you. If you like it, then do share it with your friends and colleagues, and if you are new on this channel, then please subscribe us and turn on the bell notification. And this video is exclusively for the members, so I'm going to put it in the members list, and you can join the membership program to get such type of more videos. Thank you so much for your time. See you guys in the next session. Till then, bye bye. Jai Hind. Take care.